Hello everyone, this is our 9 academic math lesson on slope. The slope of a line is the measure of a steepness of that line. Okay, let's break that down a bit. The steepness of the roof of a house is referred to as the pitch of the roof by home builders. So when you look at the roof, you can look at how steep that part is as opposed to maybe this piece here. So there's a few different roofs for you to look at and different slopes on them or different pitches. Why would some houses have a steeper pitch than others? So look at how steep this house, the roof is compared to say this one. Why would that be? That's because in the winter snow needs to fall off the roof, and so if it's very flat, the snow's heavy and it will collapse the roof. So that's an example. Engineers refer to the slope of a road as a grade. If you have your handout, you're not copying anything down yet. We're just going through these slides. I'll tell you when you'll know when we get to example 1. So these are just different roads with different steepness of grades, and they often refer to that slope as a percentage. Sometimes you might have seen a sign like that if you're driving, especially out in the country. So here's a line, 2 red dots on it. We connect the dots to get kind of a measure of the steepness of the line. So we need a way to talk about how steep a line is, or how steep a roof is, or how steep a road is. So we call that measurement that we use a slope, right? We need a way to talk about kind of how steep this is. The way we get the slope of a line is we measure the distance. We take 2 points on the line, and then we measure the distance, the horizontal distance between them, and we call that the run. And we measure the vertical distance between that, and we call them the rise. And we put them together with rise over run, and that will give us the slope. So if you saw a sign like this that said 8%, that would mean your run is 100 and your rise is 8, because we want to have rise over run 8 over 100. That's where you get the 8% from. The steepness of wheelchair ramps is also really important. The slope of wheelchair ramps is usually about 1 over 12. So what that means is, for every rise of 1 unit, whether it's 1 meter or 1 centimeter, we have to have a run of 12 of those units. So if the rise is 1.5, what is the run? So if my rise is a 1.5, we have to also change the denominator, and that would give us an 18. Determine the slope of this line. So we have a line, we've already got the rise and the run written out here. So 5 is the rise and 9 is the run. Well, where did this M come from, this letter M? We use the letter M because in French, the word for to go up is monter, or to climb, right? And so why is it French? Why is it coming from that? Remember our friend René Descartes in the Cartesian plane. He was French, and so that's why we have incorporated this M for slope. So instead of S being the short form for slope, we use M. Because the slope is a ratio, in these questions we're just talking about a ratio between the two sides. There's no units such as centimeters or centimeters squared, but we will get to explanation of that later. Determine the slope or the pitch of this roof. So I don't have a line here. I want to know how steep this is. I'm going to need some coordinates, right? So let's lay a grid over top of that, and then we take 2 points, say here, and we're going to count out the rise and the run, and then we get a slope of 5 over 3. So that's the pitch of the roof. What about the slope of this staircase? So we need to calculate the rise and the run, 3 and 2. So the slope is rise over run, 2 over 3. What about this staircase? This one has 3 and 3 for the numbers. So when I look at these staircases, this is a 3 over 3, and this is 2 over 3. If I was actually walking, putting my foot down on the flat part, putting my foot down here and walking up the staircases, which one would be steeper to climb? Well, it would be the larger number here. So this is a slope of 1, which is bigger than 2/3. So this is a steeper one. Let's find out the slope of a line on a graph. So when we have a line, we try to find 2 points. We want to find 2 points that are nice, clear intersections of the grid line. So I wouldn't pick, for example, this point here, because this is maybe a x value of 9, but the y value, I don't know what that is. So I would rather pick points that kind of cross really nicely through the grid lines. Then I draw a triangle to calculate the rise and the run, and I count it out, 3 and 9. So the formula that you have to memorize is slope equals rise over run. That's 3 over 9, and that reduces to 1 over 3. So that's the slope of that line. How about this one? Remember, the formula is rise over run, but this time we're going down. We're not actually rising, and we always start from the leftmost point to the rightmost. We don't go backwards this way. Remember, in math, we read graphs the same direction we read English, which is left to right. So to get from my left point to my right point, I'm going down. So it's not a rise. You can think of it as a fall. So we're not rising 5. It's a -5, so it's kind of like a fall. But we still run to the right. Always that's going to be a positive because we always read from left to right. So formula, slope equals rise over run. The rise is -5, and then the run is 7. So that's the slope for this line here. How about this one? Slope is rise over run. I've got 7 units there. That's my run. But what's my rise? To get from my leftmost point to my right point, what am I rising? I'm not rising at all. So when I sub into the formula, I get a 0 for the rise. What is 0 over 7? It's 0. The horizontal lines all have a slope of 0. So think about it this way. If you were skiing and you were on a completely flat level ground, there would be no slope. We would have a slope of 0. There's no incline or decline at all. How about this one? Imagine you were skiing from this point down to this point right here. Okay, we haven't got a left and a right point, so we can use either one first. So we count out our rise is 6, but what's our run? We don't have any run, it's 0. So for rise over run, we're going to put 6 over 0. Now that is not 0. This is not a slope of 0. This is called undefined. It is so steep, we can't even define it with a number. That's how steep it is. Vertical lines have slopes which are undefined. So here are all your types of slopes. Your positive ones go that way, your negative ones go down, and 0 slopes are horizontal, and the last one, the slopes that are vertical, are undefined. So this is on your sheet, and these are important generalizations to know that of the lines that go in those directions and what they are. Let's do the slope of this line. So remember what I said, we need to find the line needs to be crossing the grid lines, kind of right square through the crosshairs. So can you find 2 points on this line that do that? So for example, this is not a good one. 4 and I don't know, 45, 46, that's not that great. I'd like to find one that's a little bit better. Which points will you use to determine the rise and the run? So here's a good one. Maybe you were looking at that one. 2 and 30 is a good coordinate. And how about another one? There's another good one, 7 and 70. So notice the scale here. This time we're counting by tens, not by ones. So when I do my rise, I can't just say the rise is 1, 2, 3, 4 units, because it's not a 4. I'm counting by tens. So when I put my rise on there and my run, we've got 5 units. That's from here to here is 5 units, right? These are counting by ones, so that's fine. That's 5 units. But what about the rise? There's the rise, and that's 40 units. Slope is rise over run, subbing it all in there. We can reduce that and get 8. So we have a slope of 8 here. Again, take a look at the scale on the axes. This one's counting by tens on the x-axis this time. So I've got to be careful when I draw my triangle. My triangle's going down this time. It's below the line because the line is going down. So I know it's going to be negative. My slope is going to be negative because from my leftmost point to my right point is going down. So that's got to be a negative. So I count it out. Remember, I'm counting by tens along the horizontal. Put it into my formula, reduce, negative 130. What if you're asked to draw your own line? So you put a dot somewhere. There's a dot. Now I need to get a slope of 1 over 2. That means I need a rise of 1 from there and a run of 2. So let's count it out here. There we go. There's a rise of 1 and a run of 2, and we're assuming every grid line just counts as 1 here. We don't have a scale on here, but we're just going to assume that everything is a scale of 1. And let's try again just to be sure. Let's rise 1 and run 2. Put another dot. Do it again. They should all line up. If we're doing it correctly, they should all line up perfectly, and they do. We can put an arrow through there. So there is a line which has a slope of 1/2. Now what about a line that has a slope of 2? So put a dot somewhere. And now we need to, this is 2 over invisible 1. Remember, that's what 2 is. 2 is over 1. So we've got a rise of 2 and a run of 1. There's a rise of 2 and a run of 1. And let's just do that again. Get another dot on there. And look at how much steeper that one is than the first one. Because 2 is a bigger number than 1/2. So remember, slope is kind of how we measure our steepness of lines. So 2 is a bigger number, so of course we would expect it to be steep. And another question, let's put a dot on there. Drop 5 and run 6. Drop 5 and run 6 because we had a negative. So that one is going in the opposite direction of the ones we just did. What about a slope of negative 3? Put a dot on, drop 3, run 1. Drop 3, always run to the right. Always run to the right. Now what about positive 3? How's it going to look different from negative 3? So there we go. It's positive, so it's exactly the same steepness. If you were skiing down this one or you were skiing down this one, the steepness is exactly the same. It's the direction that's different. The negative means it's coming down. Positive from left to right is going up, but the steepness is the same when they're both a 3. Example 1. This is on your handout now. A steel beam goes between the tops of 2 buildings that are 7 meters apart. One building is 41 meters tall, there's 52. What is the slope of the beam? So remember all our strategies from word problems. In this case, we're going to draw a diagram labeling all parts. So I'm just going to try my luck with my ruler here and see how I can do with my tablet and my ruler. Doesn't always work out that well. Let's do a line here. There's one building, and move my ruler over, and whoops, that's too high. Another building. Let me just erase that part up there. Okay. So we've got 2 buildings that are 7 meters apart. So the distance between these is 7 meters. This is one building, and this is the other building. There's 7 meters in between them. One building is 41 meters tall. That'll be the shorter one. This one's 41 meters tall. The other is 52 meters tall. What is the slope of the beam? Remember what it said, the beam goes between the tops of the 2 buildings. So my beam, so my ruler isn't going to work here, so I'm just going to switch colors. I'm going to just draw a line freehand. If the question doesn't ask for a diagram, you don't have to draw a diagram. But if I do ask you for a diagram on a test or a quiz and you don't use a ruler, you will lose a mark. So use a ruler if it tells you to. This one didn't tell us to. So here's our beam right here. That's the beam. And we're supposed to find the slope of the beam. So what are we going to do? Well, we're of course going to do a rise over run. We got to turn it into a triangle. So I'm going from this point here to this point here, and I'm going to draw a triangle across like this, rise and run. So when I label the bottom, that's a 7. Now what's this distance right here going to be? How high is that? Well, I know that tall building's 52 meters and the shorter one is 41, so it must be 52 minus 41 meters tall. So it's got, so that's an 11. So we've got our diagram, which is very helpful, but we need to do a true mathematical solution here. Slope m is equal to rise over run. So our slope, the rise is 11. Is it positive or negative, that 11? So I look from left to right, I'm going up, right? That's going up from left to right, so that's a positive 11. The run is always positive because we always run to the right. That's 7. So the slope of the beam is 11 over 7. And unless the question is asking you to convert to decimals, we will always leave it as a fraction. So that's the slope of the beam, 11 over 7. Next example. Find the coordinates of point B given A is negative 3, 5, and the slope between A and B is negative 1 over 9. We're going to draw a quick graph. Again, the question didn't ask us to, but this will be very helpful to do so. So we've got A at negative 3, 5. So I'm not even going to put a lot of effort into getting all this right here. That would be a negative 3 and negative 5. 1, 2, 3, 4, 5. These may not even be evenly spaced out, but that's okay. So I'm going to put a dot here at negative 3, negative 5. This is just so that I can get a handle on this question. That's why I'm putting this here. And this is point A. A is negative 3, negative 5. And I'm trying to find the coordinates of point B. I don't know the coordinates of point B, but I know the slope between them is negative 1, 9. Negative 1, 9. So that means, let me put this here, my slope is negative 1 over 9. And I'm going to specifically put that negative in the numerator. It was in the middle there, but I need to put it in the numerator for slope questions because it can only go in the numerator. So normally I know that slope is rise over run. So instead of a rise, because it's a negative, it's actually more like a fall. Right? So I'm going to go back to my graph. I'll switch colors. Actually, I'm going to move over my label here because it's kind of in the way. Let me move it over here. A is negative 3, negative 5. So now I need to drop 1 unit from here. So I'm going to drop 1. That's my fall. And then I have to run 9. So I'm going to run 9. I was at a negative 3. So this would be negative 2, negative 1, 0, 1, 2, 3. So I'm trying to count out a run of 9. So I might lose my spot here. So maybe I should label a few more on my graph. 1, 2, 3. I'm not going to have enough room. I'll just keep going here. 4, 5, 6. Oh, I'm not really sure how to go. Let me just go all the way to 9. I don't think I'm going to need to go all the way to 9, but let me just put them all on there. That's my x-axis. So how far do I need to go if I'm running 9 from a negative 3? So I started at negative 3. I started at negative 3 down here, this point, and I've got to run 9. So do I land at 9? No, because I've already got 3 over here. So I'm moving 3 units this way, and then another 6. That will give me 9. These 3 units, and then 6 more will give me 9. So I'm going to end up right here, roughly. So what is that? When I say roughly, I mean because my graph isn't great, but the coordinate has to be right. What's that new coordinate? So here's my new coordinate B. And the question said, looking up at the question, find the coordinates. So let's start with the x value is harder. Let's start with the y value. So here's my x, here's my y. My y value, I was at a negative 5. That's where A was, and I had to drop it 1. I had to drop it 1, so that's going to be a -6 now. So that's my y value is a -6. What about my x value? So our x value is a 6 because we had to go from -3 over 9 units. That would take us to a 6. So there's our find the coordinates. So therefore, B has coordinates. 6, -6. So that's a question like that. When you get to questions like this in your homework, come back and look at the examples so that you can follow them to know what to do. Example 3. This is our last example. A wheelchair ramp must have a slope of 1/12 to be safe. We saw that in the beginning slideshow. The front door of a home is 1.7 meters above the ground. What length along the ground must the wheelchair ramp run? Draw a diagram. Okay, we have to draw one this time. So I've got the front door of a home, like that. Let's say that's the front door. So this would be the front door, and put a D here for the door. And this is the ground, G, because the front door is 1.7 meters above the ground. Think of your front door at your home or somebody's home. Usually you have to go up a few steps to get to the front door. You do not walk right from the sidewalk, usually straight in your front door. Even if you're going into an apartment, you always go up. So there's the front door in the ground, 1.7 meters. Well, that's this piece. The front door of a home is 1.7 meters above the ground. We got that. And the other piece of information we have is that a wheelchair ramp must have a slope of 1/12 to be safe. So the wheelchair ramp, a ramp, definitely. We're going to draw the ground here. Let's see if I can do this with my. Whoops. So we should be getting a straight line here. There's the ground. That's supposed to be level. That's the ground. And we need somebody to get in this front door here. There's a front door. There's a doorknob. We need them to get in the door, but we need a ramp to get them up there. So let's draw a hypotenuse for this triangle here, if I can. Okay, good enough. So here's our ramp. This is our ramp right here. That's the ramp. Now, if the ramp must have a slope of 1/12, so we have a slope of 1/12. That's the ratio that it has to be in. So to break this down a little easier, if I had a ramp that had a if I had a ramp that had a rise of 10, it would have a run of 120, because that's in the same proportion as this one, right? This one reduces to 110, this 1/120. If I divide them both by 10, I'm going to get 1/12. So I need to keep it in the same proportion. So I've got, let me put it over here. So we're going back to what we know about proportions. 1/12 has to equal something. So this is the top number is the rise, the bottom number is the run. We know we have to have a rise of 1.7 because that's how high our front door is. So we have to have a rise of 1.7. How am I going to figure out the run? So I'm going to change that question mark to an X. Change that to an X. And then we are going to cross multiply. So I'm going to multiply this X up to the 1. And I'm going to multiply the 12 up to the 1.7. So X times 1 is just X. And there's my equal sign. And now we have to do 1.7 times 12 to cross multiply the other denominator up. That's 20.4. So what length along the ground must the wheelchair ramp run? So this distance down here, we call this X. That's got to be 20.4. So we need a sentence. And the ramp must run 20.4 meters along the ground. So there's a word problem similar to something you might have in your homework. Always come back and check out the videos again when you get stuck on the homework. When you have a question that asks you to plot, if it tells you here's 1 point on an X and Y axis, count out a slope of 2, you've got to use graph paper when you're asked to plot. That's the end of our introductory lesson on slope.